Today, we are pulling back the curtain on some of the invisible magic that happens inside your computer. We're going to explore the incredibly complex systems that manage every single piece of your hardware, making it all just work from the moment you plug something in. I mean, really think about that for a second. You plug in a new mouse, a keyboard, a flash drive, and boom, seconds later, it's ready to go. You didn't have to do anything. How does your computer know what that thing is, let alone how to use it? Well, that's the big mystery we're going to unravel today. To really appreciate this magic, you have to remember how things used to be. The old way was, well, it was a nightmare. You had to mess around with driver disks, manually configure these things called IRQ settings, and just pray you didn't cause a conflict that would bring your whole system crashing down. Today, we have Plug and Play, or PNP, and it handles all that mess for us, automatically. So how does Plug and Play actually pull this off? Well, the very first thing your operating system needs is a complete map, a blueprint of every single component connected to it. It has to know what's there before it can even think about what to do with it. And the most fundamental building block of this hardware map is something called a dev node or device node. The easiest way to think about a dev node is like an employee file in a giant company. It's this little packet of data that represents one specific device, and it has all the critical info, what it is, what resources it needs to run, and what its current status is. Now, all of these individual dev nodes, these employee files, are organized into a big hierarchy. We call it the device tree, and it really is just like a corporate org chart for your hardware. At the very top, you've got the computer itself. That's the CEO. Reporting to the CEO are the major departments, like the PCI bus, and under them, you've got managers, like a USB controller. And finally, you get down to be individual employees, your keyboard, your mouse, all perfectly organized in the chain of command. Okay, so the system has its map, it sees a new device has shown up for work. But how does it actually manage that device? Well, for every single piece of hardware, Windows puts together a specialized project team of software components. We call this the driver stack. And no, it's not just one driver, it's a whole team. This project team, the driver stack, has a really clear structure, like a chain of command. Each layer in the stack has a very specific job. It all starts with the bus driver at the bottom, then you have the function driver in the middle, and sometimes you'll have these optional filter drivers layered on top to add some special skills. So the first member of the team is the bus driver. Its job is super simple but absolutely crucial. It's basically the lookout. It watches the bus, say a USB port, and the second it sees a new device, it shoots its hand up and tells the PNP manager, hey, we've got a new arrival. It then creates what's called a physical device object, or PDO, which is like the official birth certificate for that device in the system. Next up is the function driver. Now this is the star player, the specialist on the team. It creates the functional device object, or FDO, and it's the one that actually knows how to make the device do its job. If the device is a webcam, the function driver is the piece of software that knows how to capture video from it. It's the real workhorse. And finally, we have the optional filter drivers. I love this analogy. Think of these guys as consultants. They can jump in and layer themselves above or below the main function driver to either watch what's happening or even change it. A great example is a filter driver that adds encryption to everything being written to a hard drive. It doesn't change what the hard drive is, it just adds a new valuable feature. So, Plug and Play was a huge win. It solved the absolute chaos of installing hardware. But as our computers, especially laptops and phones, became always on, a totally new problem popped up. An incredible thirst for power, and the desperate need to save every last bit of battery life. The old way of managing power was, let's be honest, pretty clumsy. You could put the whole computer to sleep or maybe turn off an entire device, like your graphics card. But think about a modern smartphone that means to check for emails while the screen is off. This all-or-nothing approach is just way too slow, and it wastes a ton of power. The solution? Well, we had to build a much more intelligent system. To solve this power problem, modern operating systems develop something like a smart grid for energy, giving them incredibly precise, fine-grained control over every little component. And this brilliant solution is called the Power Management Framework, or POFX. Here's the key. Instead of managing power for an entire device, POFX lets drivers manage the power for individual components inside a single device. It's like a smart office building that can turn off the light at one empty desk instead of shutting down the power to the whole floor. It's that precise. So this shift in scale is what's so important here. We still have system power states. Those are the S states like sleep and hibernate that affect the whole computer. But POFX introduces component power states, or F states, that apply to tiny parts of a single device, even while the rest of the device is technically still on. This whole system works using these F states. F0 is easy. That's fully on, full power, ready to go instantly. As you move to other states, like F1 or F2, that little component uses less and less power. So what's the catch? Well, it's a trade-off. The deeper the sleep state, the more latency there is. It just takes a tiny fraction of a second longer to wake back up to that fully on F0 state. And why should you care about any of this? Because the benefits are things you experience every day. Since components can sleep and wake up super fast, you get much quicker resume times from idle. This super granular control means a huge reduction in power use, which means longer battery life. And it's what makes modern features like connected standby possible, where your laptop can still get notifications while using almost no power at all. All right, let's bring this all home. We've looked at two incredibly complex systems that are constantly working behind the scenes. They're totally invisible to us, but they're responsible for creating that smooth, efficient experience we all expect. Here's the big takeaway. Plug and Play is like a city planner. It's constantly building and updating this detailed map of all your hardware and assembling the perfect teams to manage everything. Then, the Power Management Framework, POFX, acts as that city's smart power grid, intelligently sending power only where it's needed, optimizing it right down to the individual desk. It's these two working together that makes it all feel so effortless. And that kind of leaves us with a final question to chew on. As our devices get even more complicated, with CPUs that have both big performance cores and tiny efficiency cores, is that line between the hardware city map and the software power grid going to start to blur? Could they eventually just merge into one single self-managing system? It's a really interesting thing to think about for the future of computing. Thanks so much for tuning in.
If you want to help me out, please smash that like button, leave a random comment, and subscribe if you want to become a better hacker.